This is my Physics 2 Lab 2. The purpose of this lab is to compare the theoretical models of a point charge system to a system of line charges. We will use Newton's second law and Coulomb's law within the GlowScript code to estimate the charge in each piece of tape. The data inputted into the lab is from the estimations gathered in Lab 1. The formulas described are shown on the right. The system in this lab is both pieces of tape and the Earth, while surroundings is everything else in the universe. In this lab, we assumed that the surroundings had a negligible effect. In this lab, we also assumed that the charges are distributed equally, each piece of tape is the exact same charge, air resistance is negligible, and the tape exists in one dimension as opposed to two. The mass of the tape was estimated to be 0.0004 kilograms or 0.4 grams, while the charge of the tape is shown as well as the distance between the pieces of tape. And the results preview is that the magnitude of the electric force in the model is 1.00521 e to the negative 3 coulombs, while the magnitude of the gravitational force is larger. To summarize Lab 1, in Lab 1 we charged tapes using a given method, creating two positively charged pieces of U tape. We then calculated the charge based on if the tape consisted of a single charge and resulted in the following values. This was also done in GlowScript. Beginning parts of the code for this lab is shown here. PHYS refers to 1 over 4 pi epsilon naught, which is used for electric charge calculations, while the gravitational constant is shown right below that. Mass of the tape is also shown here, as well as the estimated net charge on the tape based on Lab 1. The function we created in Lab 0 is next, as well as the function for the line charge, as provided through the lab rubric. How the top tape and bottom tape interact is described here, with the top tape being created as a line of charges as well as the bottom tape, with n referring to the number of charges simulated in the line of tape. For my lab, I chose to use 100 in each piece of the tape. The functions below describe how the tapes interact with one another, as well as the magnitude of the gravitational force on the tape as calculated using Newton's second law. All of the calculations for forces between the tapes is calculated using Coulomb's law. Some results and conclusions of this lab is that, as we know, electric force and gravitational force cancel out when the tape is not moving. The formula for the electric force is shown here, which has allowed me to calculate the charge of each piece of tape, which is Q. Potential errors present in this lab is that the charges may not be the exact same on each piece of tape, the charge may not be evenly distributed between each piece of tape, as well as the data from Lab 1 has to be exact for this lab to be exact, which it may not be. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with the line charge model. Well, in the single point charge model, we got an estimate for the charge of each tape at around 1.98 times 10 to the negative 8th coulombs, while in this lab we got 49.4% lower as the estimation for each piece of tape. Now the estimate being around 1 times 10 to the negative 8th coulombs. Significant difference. Why? Why do these estimates differ? Which value is more likely to be closer to real value and why? These values differ because the line charge takes into account forces from each charge on every single other charge between the two tapes, not assuming the charges are really far apart, which we had to do to use the single charge model. For this reason, the line charge model is likely more accurate as the tapes are not a significant distance apart. In fact, they are extremely close, with the distance between the tapes being lower than the length of each piece of tape. This concludes my lab 2.